Hello everybody, welcome back to the next lesson in the, or rather the next chapter in the reasoning course. We are doing the chapter on network diagrams now. We have already completed games and tournaments, and I'm quite sure games and tournaments, apart from the lessons I've done in the basic course, you'll find a lot of questions or a lot of discussion of games and tournaments also in the 50 must watch course, which is why I have awarded games and tournaments at this point. Maybe I'll do one more addition to the games and tournaments chapter with a cat question on cricket tournaments. But football and hockey we have discussed in football, hockey and tennis tournaments we have discussed in details in the games and tournaments chapter. So I'm moving into the network diagram chapter today. Our network diagram chapter again is an important chapter. It's very commonly asked. You will see a lot of logic around this. And basically, ऐसा कोई मतलब these you need to understand that these are not chapters like the chapters of mathematics. These are not well-formed chapters in that way. But yes, different types of questions in reasoning have some way, some commonality in terms of how you think. So, we start with the network diagram chapter here, and the first thing I want to discuss. I mean, network diagrams basically are about moving from one place to another. It's about routes and networks, whether it's a route or road network, or it is a pipeline network or something like that. So the first aspect of a network diagram, or the first thing that you need to visualize in a network diagram, is how many routes there are to move between one place to another. So if I give you, let's say, a very simple diagram like this, there is a point A, there's a point A or a city A which leads two routes out, and one of these routes goes to B and the other route goes to C, and from B and C you have a route to go to D, where you have a route from B to D and you have a route from C to D. And if I ask you this simple question, how many routes are there to go from A to D? So it's a very simple situation, very commonsensical situation that you can see. There are essentially two routes from A to D, A, B, D and A, C, D, right? And इसको count करने का क्या process है? मतलब ठीक है, यहाँ पे तो count is simple. But if you want to think of a situation or a structure under which you want to count this, you can think about your journey being in three stages. This is stage 1 of your journey. This is stage 2 of your journey. And this is stage 3 of your journey. So you can think about how many ways are there to move from stage 1 to stage 2. So, I mean, of course, you don't need to do all this in this question, but I'm still showing this to you because when the problem you will face is when there are 10, 12, 15 routes to be counted. Those time your counting has to be correct and exact. So you cannot make mistakes in your counting like this. So I'm just trying to show you a system that will give you the number of routes without making a mistake in it. So stage 1 to stage 2 जाना है, मतलब A से you have to go to either B or C. There are two routes to go from stage 1 to stage 2. And when you go from stage 2 to stage 3, the journey basically from A to D is where you're moving from stage 1 and you're moving all the way to stage 3, because stage 3 is only D. So when you're moving from stage 2 to stage 3, if you are in stage 2, you have only one, you will either be at B or you will be at C. You cannot be at both. So if you are at B, you have one route to go to S3, and if you are at C, you have got one route to go through to S3, from S2 to S3. So S2 to S3 will always be one route, although it seems that there is a first route and a second route, but you don't count it that way. You have to think about where you are and how many ways there are to go ahead. So this is the structure. So once you do that, the very obvious count of 2 is also replicated in this thought, where you get 2 into 1 is 2. And you need this thought to be able to think in slightly more longer questions. So if you are understood this, maybe I'll show you one case now where I have a figure with for you, and I want to ask you how many routes are there to go from A to G. You want to travel from A to G. You want to travel from A to G, and how many routes are there to go from A to G? So in this case, if you do the same logic, the same thinking, the stage-wise thinking, what will happen is you will see that if I think of this as stage 1, I've got 3 routes moving out of stage 1 to stage 2, and B, C, D are stage 2, and E, F is stage 3, and G is stage 4. So if I think of how many routes there are in this case, I can think of from stage 1 to stage 2, I've got 3 routes, because if I'm in stage 1, I'm at A, and to go from A to stage 2, it means I can go either to B or C or D. So there are 3 routes from stage 1 to stage 2. How many routes are there from stage 2 to stage 3? This is one critical part of your thinking that I want you to organize. Normally what people do is, as I told you in the previous question, you can see 1, 2, 3, 4, 5 and 6. 1, 2, 3. I mean, let me just write those. You can see 6 routes here. 1, 2, 3, 4, 5 and 6. But if you actually look at it, these routes all originate at different positions. They are not all originating from the same point. So that is the reason why you don't talk about 6 routes from stage 2 to stage 3. If you are in stage 2, you would have reached through one of these 3 routes, you would have reached either B or C or D. And wherever you reached, you got 2 routes to go ahead. Whether you reached B or C or D, to reach stage 3, you've got 2 routes to go ahead. So that is why this would be 2, and when you are at stage 3, you are either at E or F, and from E going ahead or from F going ahead, you have only one route, which is why the total number of routes in this figure is 2 into 3 into 1, which is 6 routes. Now the problem gets compounded or becomes more difficult in case you have an asymmetric picture. So how do you handle an asymmetric picture? So let us try to, so what is happening, you need to understand, before you understand asymmetry, you need to understand what symmetry means. So this figure that I have used till now is a perfectly symmetrical figure. Why? Because all the nodes of stage 2 are equal to each other. They are all equal to each other. I mean, they have got one route coming in, 2 routes going out. All the nodes of stage 3 are equal to each other. All the nodes of stage 4 are equal, I mean, there's only one node of stage 4. But suppose you have a case where, let's say, we make these routes or these nodes asymmetrical. We say that this route doesn't exist. So in that case, you will have to treat B and D as separate structures, because B and D are symmetrical to each other, and C as a separate structure. And now you no longer have 6 routes, because now what you will have to do in this case is I mean, I'm explaining the first way in which asymmetry can happen, in which one of the nodes in the second stage or the third stage does not have the same number of routes as the others, because some of the routes are blocked or something like that. So in this case, you will have to think of B and D. Now try to write down your structures. How many structures does one have? You have a structure which is taking you, from stage 1 to stage 2A to stage 3 to stage 4, and the other structure is taking you from stage 1 to stage B, 2B to stage 3 to stage 4. So when you start thinking about how many routes there are for each of these movements, you can think that when I'm going from stage 1 to stage 2A, that means I'm going to either B or D. So there are 2 routes leading from stage 1, which is A, towards either stage 2 or stage 2A. That's either B or D. So there are 2 routes from stage 1 to stage 2A. From stage 2A to stage 3, if I am in stage 2A, I am either at B or I am either at B or I am at D. And moving ahead to stage 3, I have got 2 routes each. So stage 2A to stage 3 is 2 routes. And stage 3 to stage 4, when I am going from stage 3 to stage 4, I am either at 3 or F, E or F, and I am going to C, I am going to G, so which has got 1 route. So this movement of stage 1 to stage 2A to stage 3 to stage 4 has 2 into 2 into 1, which is 4 routes. And then you have to count the other one also. So you have to first get that structure correct. So you have to count the other one also. So stage 1 to stage 2B, that means you are going from A to C. There's only 1 route because there's only 1 position in stage 2B. So you'll have to come to C, and from A to come to C, there's only 1 route. And if you are at C, going to stage 3, there's only 1 route again because you don't have an F route. This route, remember, was cancelled. This was not allowed. So C to E is the only route. So to move from stage 2B to stage 3, if you are in stage 2B, you are in position C or node C in this network. And to move ahead to stage 3, you have got only 1 route. And then from stage 3 to stage 4, if you are in stage 3, in this case, you'll necessarily be at E. And from E, moving ahead to stage 4 is 1 route. And since you have to do each of these parts of the journey, so using the logic of counting and the AND usage here, you have to do stage 1 to stage 2B, and you have to do stage 2B to stage 3 and stage 3 to stage 4. Hence, the number of routes is 1 into 1 into 1, which is 1 here. So the total routes in this picture, if I have closed this route, is 5, which you can, of course, in this case count directly also, but sometimes it gets complicated, and you have to be able to structure it correctly. Suppose I make a different kind of structure. Let's say I close this route, and then I introduce a route BC. I introduce a route BC, and I also introduce a route CG. I also introduce a route CG, and then I ask you to count how many routes there are in this network. I would want you to pause the video before you watch my solution, and I'll want you to pause my video before you watch my solution. Try to think about this. You can see the picture, and I'm asking you to count the number of routes correctly in this case. So if I think about this situation, I realize that there's absolutely no symmetry here. First of all, at least in the stage 2, B is different from C, and both B and C are different from D. And not just that, C has a different angle because C is also connected directly to G, bypassing E and F. So the first decision here in this question, when you're trying to count it accurately, and this is the reason you need to count stages. Otherwise, what happens if you're counting A, B, C, E, G, A, B, C, F, or A, B, F, G, and A, B, E, G, if you're counting the routes like that, by the time you've counted your 5th or 6th route, you will get completely confused about kaun sa count ho gaya, kaun sa count nahi hua. You'll get completely confused about which one is counted and which one is not counted. So that is the reason you need to have this structure in your mind. So my structuring in this case will be A ko I'll call stage 1, B ko I'll call stage 2A, C ko I'll call stage 2B, D ko I'll call stage 2C. E and F, because the routes into E and routes into F are not symmetric, but route out of E and route out of F are symmetric. So we are more bothered about the routes out. So both these can be referred to as stage 3. Now the first objective in this counting, to make sure we are counting correctly, is we are going to first structure down how many routes do we have stage wise, or how many structures do we have stage wise, and then we count each of them separately. So one structure is S1 to S2A to S3 to S4. Of course, I'll be taking G as S4. But then there's another structure of S1 to S2B, sorry, to S2A to S2B. Remember there was a route connecting B to C. So from B I don't only have the option to go to S3, I also have the option to go to C, which is S2B, and from here I've got a route to S3 and then to S4. This is my second structural route in this case. And my third structural route is because C is also directly connected to G. Once I come to S2B, I can straight away go to S4 also. So my third structural route here is S1, S2A, S2B and S4, because in my picture I can see that if I go S1 to S2A to S2B, I have a exit route directly to S4 which I should count. So this is my routes for going through S2A. Now then I'll think of my routes going through S2B. Remember this one was S2B. This was my structure. So if I am going through this directly, my routes are S1, S2A, followed by S3, followed by S4, and I also have a route of S1, S2A. Why am I writing S2A here? S1, S2B to S4. I got a route from S1 to S2B to S4. That's my second structure. And then of course I can think of what are my routes from A to D, which is basically S2C. So if I go S1, S2C, that means in my original picture if I come A to D, I only have a direct route to S3. I don't have a route any longer now to S2B, so I don't need to count that double. So S1, S2B, S2C to S3 to S4 is my routes. S1, S2C, S3, S4. And I should be able to confirm that there is no other route structure that I have missed. Because if I miss a route structure in this question, obviously my number of routes will be wrong. And once you have done that, the game starts moving into counting each of them. So how many routes do you have to go from S1 to S2A? There is only one route here, because you will go to B. And S2A to S3, if you are going from B to S3, you got two routes. You can either go to E or F. So if you are at B, if you are at this position, going forward to S3 is two routes, and from S3 to S4 there is only one route again, because if you are at S3 you are either at E or F. So S3 से F4 जाने का एक ही route होगा. So this logic will give me one route. So the number of routes here is 1 into 2 into 1. So I now have two routes for going from A to G. The second one is what happens if I am going from S2A to S2B. My second route structure. S1 to S2A is one route. S2A to S2B, that means B to C is one route. S2B to S3. S2B to S3 is also one route. Remember, if I am at S2B, I am at C, and I have to go ahead to S3, and S3 is this structure. So if I have to reach either E or F, from C I cannot reach F, so I'll have to reach E. So that's only one route to move ahead from C. So this is S2B to S3 is also one route, and S3 to S4 is also one route. So 1 into 1 into 1 into 1 is one route through this route structure, and then S1 to S2A is 1, S2A to S2B is 1, S2B to S4 is also 1. So there's one route here also. So I got four routes going through S2A. And then if I go into routes through S2B, I go S1 to S2B, one route. S2B means I'm here. Remember S2B, this to F was cancelled, this was the route available. So S2B to S3 is one route and S3 to S4 is one route. So there's only one route in this direction, in this structure. And then S1 to S2B one route, and S2B to S4 directly is also one route. So that's one more route. See, the key is it's a simple structure, it's exercise, but the key is to make sure that you're not missing out any of the structures. And that's why it's important to understand how many substructures you are able to build from S1 to S4. And then finally, so we had 4 on the previous page, and we now have 2 more. We had 4 here, 2 plus 1 plus 1, and we have got 2 more. This is 1 overall, and this is also 1 overall, so 6. And I now need to count S1 to S2C, which means I have to go to D. There's only one route to go to D from S1. And if I'm at S2C, it means I'm at the position D, and from D to move ahead to E or F, I've got 2 routes to move from S2C to S3. So S2C to S3 is 2 routes, and S3 to S4 is 1 route. So this has got 2 routes more. So there are a total of 8 routes which are available in this case. Of course, you had the option of numbering these routes differently also. You could have or numbering these nodes differently also, given that this was given and this was given and this route was eliminated. You had the option of calling this S1, calling this S2, calling this S3, calling this S4, calling these as S5. You will not segregate these two because they are not needing to be segregated. Of course, you can call them S5, S6. तब तो फिर तुम एक-एक करके routes गिन रहे हो. But you want to aggregate them wherever symmetry is there. So E and F are symmetrical going forward. So this is S5, and that is S6. So in which case you could write routes like S1, S2, S5, S6, S1, S2, S3, S5, S6, S1, S2, S3, S6. So you can, if that sounds better to you, you can actually use that structure in a situation like this. So one more situation, an asymmetric situation. I want you to count the number of routes here. Try to do it yourself before I help you with it. So let's see, what will you do? What will I do? I'll call this stage 1. B, C, D are all symmetrical to each other. So let's call B as stage 2, C as stage 3, D as stage 4. Right? And EF is stage 5. And last one is stage 6. So what are my routes now? The first route is S1, S2, S5, S6. How many routes do we have there? S1 to S2 is one route. S2 to S5 is 2 routes because from B to E or F there are 2 routes. S5 to S6 is one route. So 1 into 2 into 1, 2 routes on this. S1, S2. So first we are looking at routes through S2. Then from S2, instead of going to S5, I also have an S2 to S3. So I can use an S1, S2, S3, S5, S6. How many routes do I have through that? S1, S2 is one route. S2 to S3 is the forced route again. I have to go BC. S3 to S5 is 2 routes because if I am at S3, to move to S5 I can go either to E or F. So there are 2 ways for me to shift my stage from S3 to S5. So this is 1 into 1 into 2, and from S5 to S6 there's one route. So there are 2 routes. S1, S2, S5, S6 is 2 routes. S1, S2, S3, S5, S6 is 2 routes. So that's 4 routes total till this point. And then if I look further, what is my next structure? I have completed S1, S2. So my next structure is to think of what happens if I go straight from S1 to S3. So if I go straight from S1 to S3, from S3 I can go to S5, and from S5 I can go to S6. So S1, S3 is one route because I have to go to C to reach S3, and from S3 to S5 there are two routes, because if I'm at S3 I'll be at C, so I'll have two routes to go to E or F, so two routes there, and from S5 to S6 one route. So this is 1 into 2 into 1. So a total of two routes on this, S1, S3, S5, S6. So through S2 I've got four routes. Through S3 alone, without S2 I've got two routes. Of course, two of these four routes through S2 are through S3 also. So when I say four routes through S2, I mean routes only through S2 and routes through S2, S3. And so I'm trying to say that my first movement was S1, S2. Then I've got four routes. If my first movement is S1, S3, I've got two routes. And then I think about if my first movement is S1, S4, that means I'm going to D. So there's one route there. And there are two routes to move from D to E or F. So there's 1 into 2 into 1. So ultimately you have to be able to count it this way without doing the sub-writing, because you have to get more proficient about this. And being able to understand the number of routes is the starting point of network diagrams. And once you understand the routes, uske baad then there are loadings on the routes. Loadings like what is the cost of the travel on the route, or loadings like how much if it's a pipeline network, then how much liquid are you sending from one place to the other. So those kind of questions. And then third kind of loading is so either cost loading, or the cost of travel loading, or the time of travel loading on the routes, or the amount of liquid that can be transported. Those kind of loadings are there on routes. So in the next class on this, since this is the first session on network diagrams, I don't want to enter that part right now, but I'll just give you a precursor to what I'm showing, what I mean. This is a question from CAT, if I don't remember wrongly, this is from CAT 2000, and this is a pipeline network that is where oil is flowing, material is flowing from one location to another, and they are talking about how much is the requirement of this material at each of the junctions, and how much is the flow in the pipes. So, and what is the capacity of the pipe. So these kind of structures start happening when you're talking about network diagrams. So we'll look at these and a few more questions on network diagrams in the next lesson. Abhi ke liye I'll take your leave, and see you then, and we'll see you in the next class. I hope you enjoyed this one, and bye bye.